Chapter 9 is data analysis. And in Chapter 9, we're going to construct different types of graphs. And then once we make them, we're going to take the information and we're going to analyze the information that's in the graph. And we're going to start with scatter plots. That's the first type of graph that we're going to do. So let's take a look. Okay. Before we start scatter plots, we just need to review one thing. Okay, remember back in, I think it was Chapter 3, we talked about slope. Okay, what I want you to do on your grid in your packet, I want you to just sketch some lines that have positive slopes and some lines that have negative slopes. You don't have to be precise, and I don't even want to know what the slope is. Just graph lines with positive slopes and lines with negative slopes. So go ahead and pause the video and do that quickly. Okay, so if you remember, lines that have positive slopes start left to right and they go uphill. So there's a line that has a positive slope. Here's a line that has a positive slope. So if you're moving left to right, these are all positive. For negative slopes, these are the slopes that go downhill. If you're coming here, this is a negative slope. This is a negative slope. So if you just have some examples of positive and negative slopes, that's fine. And we need to know this because it's going to affect how we analyze scatter plots. Okay, the table shows the temperatures in Celsius and the corresponding temperatures in Fahrenheit from a local weather station. Graph the ordered pairs, Celsius first, then Fahrenheit. Is the slope of the line passing through the points positive or negative? So right now, here are your ordered pairs. Go ahead and plot them, and then we'll take a look. So pause the video and go ahead and plot them. Okay, after you have plotted these points, this is what it should look like. Okay. Now you should see this sort of looks like it forms a line, right? Now in scatter plots you never connect the dots. Do not connect the dots. Okay? But you can see that it forms a line. So this actually has a positive slope because it's going uphill, left to right, uphill. Okay? Let's look at some vocabulary when we're talking about scatter plots. Two vocabulary words that we're going to talk about. The first one is bivariate data. Okay, bivariate data is just like a fancy word to say two variables. Okay, the prefix bi, we've talked about, means two, and variate is just another way of saying variable. So two variables or bivariate data. And our two variables are our x's and our y's. Okay, but with scatter plots, they aren't necessarily x and y's, they mean something. Like in the last, it was Celsius and Fahrenheit. Okay. Now the reason that we use scatter plots is because it shows relationships between two sets of data. Okay, and after we plot it, we can look to see if there is a relationship. The graph tells us, is there a relationship between the two sets of data? So what you need to highlight here is relationship. Okay, that's the important word. That's what goes back to scatter plot. Scatter plot equals relationship. Okay, let's take a look at an example here. Construct a scatter plot of the number of viewers who watched new seasons of a certain television show. Okay, it says let the horizontal axis, or the x-axis, be the season. The vertical axis is going to be the viewers per million. So here are your ordered pairs, 1 and 31.7. So you go over 1 up to 31.7, over to 2 up to 26.3. And after you plot that, you can kind of see you've got sort of like a negative line going here. Okay, but the first part, just work on practicing plotting them. We'll analyze it here in a little bit. Okay, so for your got it problem, they want you to take these two variables, weeks and pounds, or x and y, and they want you to plot them and make your scatter plot. Make sure that you label your x-axis and your y-axis accordingly. Okay, so pause the video and go ahead and do this graph. Your scatter plot should look like this, or close to it. Okay, you can see we've kind of got a nice linear pattern going here. Okay. Your axes should be labeled the following: weeks along the x-axis, weight going up the y. Make sure that for weight you have it in pounds so that they know we're measuring in pounds and not ounces or kilograms. Okay, so that's the basic. That's how you graph a scatter plot. Okay. Okay, you just graph your points. Now, here comes sort of the new part for you guys. You guys have done scatter plots before, but what we're going to do is we're going to analyze them now. What does this scatter plot tell us? Okay, there are three things we're going to look at when analyzing a scatter plot. Okay, the first thing we're going to look at is called variable association. Okay, variable association looks at it, do we have a positive relationship? Do we have a negative relationship? Or we could have no relationship at all. Okay? What a positive relationship or association means is as your x increases, so does your y. Okay, so whatever you have along the x-axis, as it gets bigger, so does your y value. So if you take a look, you can see these are going uphill. So this is a positive association. Negative is just the opposite. As x increases, your y decreases. So you can kind of take a look. This sort of looks like our negative slopes. It's going downhill. So this is a negative association. Then sometimes you have scatter plots where you've just got points all over the place, meaning that there's not going to be a relationship. Okay? There's no association between your two variables. Okay? So this is the first thing we need to look at. Do we have a positive, negative, or no association or relationship? The second thing we're going to look at is called linear association. Okay? And all this is just saying, do we have what looks like a line where the data points are lying in a close line? Or do the data points have kind of a curve? Do you see how these kind of still stay together, but they curve a little bit? Maybe if I drew this line in, it would help you a little bit here. So here you can see these points follow a straight line. That's supposed to be straight. Okay. But here they don't follow a straight line. They kind of follow a curve up this way. Okay. This obviously is linear. This is nonlinear. So that's linear association. Linear or nonlinear. Or maybe it's neither. Okay. If you look up here, this doesn't have any association. But you can see this. This is a negative linear. This is a positive linear. Okay? So those are the first two we're going to look at. You have to determine is it positive, negative, or none. And is it linear or nonlinear? The last one we're going to talk about, you just have to look, and I know you've heard these words before. You could have a cluster. A cluster is a group of points that are really close together. You can see how these ones are kind of close or clustered together, and then you kind of have your points out here. You can also have an outlier. An outlier is a point that goes away from all the data. It's kind of like the one that doesn't fit in. It's just off by itself. Okay, so that's the third thing you need to take a look at. Let's look at an example here. Interpret the scatter plot of the data for the amount of memory in an MP3 player and the cost based on the shape of the distribution. Okay. Now, normally we know this. The bigger, when you're buying memory for an MP3 player, like an iPod, when you buy an iPod, the bigger the memory, the more it's going to cost. Okay? The bigger the memory, the more it's going to cost. So as your X increases, as your memory increases, so does your Y, or your cost. Okay? If we take a look at this graph, let's look at our variable association. Again, variable just looks at, is it positive or negative? Well, this is kind of going up. It's going to be positive. Again, because as the memory increases, the cost increases. That's a positive association. Now, let's take a look. Is it linear? Yeah, it is linear. They kind of, this one's a little harder to tell, but we don't see any curves or anything. It's kind of all going uphill. So this would be linear association. Okay. Are there any other patterns? This is your clusters or your outliers. Okay, there's not really any outliers. I guess you could make a case for this one right here, but it's not like out here or down here, so that's not really an outlier. Are there any clusters? Well, if you take a look at, I see a couple clusters. Maybe a cluster here and a cluster here. okay? And this is how they say it. There appears to be a cluster of data. 1 to 2 gigabytes of memory costs between $30 and $75. So right in here is your cluster, and they just explain it like that, okay? Let me help you with the first got it problem, okay? Here's what I want you to do first. I want you to tell me, is it linear or nonlinear? Is it positive, negative, or neither? Are there any clusters or outliers? So you've got 3 pieces you have to do here, okay? So if we take a look at this one looks like it's linear, okay? It's going downhill, it's linear. So we're going to circle linear. This is going to help us write our final answer. Okay? Is it positive, negative, or neither? Well, look, it's going downhill. Okay? As your time increases, the temperature decreases. Okay? As the time increases, as you get bigger this way, your y values get smaller. This, since it's going downhill, is negative. Okay? Are there any clusters or outliers? No, there aren't any clusters or outliers. Okay? Now, once you do that part, this can help you write your final answer. This is not your final answer. Okay? Look what I have for my final answer here. As the time increases, the temperature decreases. Therefore, the scatter plot has a negative association or relationship. Okay? As this increases, the y decreases. That's negative. Now let's talk about up here, this point right here. The data forms close to a line, so the association is linear. And then I say there are no clusters or outliers. That's how you have to set up each problem when they ask you to interpret. Okay? That's what interpret means. You have to write this paragraph out, but use this to help you write your paragraph. Okay? Use this as an example, and I want you to try C. So pause the video. Okay, let's see what you did here. Linear or nonlinear? Positive, negative, or neither? Clusters or outliers? All right, let's see what we got here. Okay, you can see these points are kind of all over the place. Okay, it doesn't form a line and it doesn't form a curve. So really, in this case right here, it's not linear and it's not nonlinear. Okay, it's neither. And you can have that. Positive or negative slope, do these go down or do these go up? Neither. Okay? And there aren't any clusters or outliers because they're all clusters and outliers. They're all over the place. So to do this, you would say the points do not appear to form a line or a curve, therefore there is no linear association. And because it's not linear, there's also no variable association, meaning it's not positive or it's not negative. And there are no clusters or outliers. So all I've done was I've taken these 3 points and I've kind of formed them into a paragraph. Okay? Okay, they want you to, and here's another example, okay, and if you want to pause the video and read through that, you can. The last one, they want you to do the same thing for got it problem D. Okay, so pause the video right now and try example D. Okay, let's see what we have here. If we take a look, this is definitely linear. Okay, you can see that it forms a line. Okay, and it's going downhill, so it's negative. And I don't see any clusters or outliers. There aren't any points off here or down here. Okay, so take that and you should have written an example or a paragraph. Okay, let me move this up. The scatter plot has a negative linear relationship. You can write it like that. Negative linear relationship. There are no clusters or outliers. And then it does ask, make a conjecture about the winning time in the 2006 Olympics. 2016 would be right, going up by 8, right about here. So you can kind of make a prediction about 45 or 46.5 seconds. Okay? All right, go ahead, try your guided practice problems, and we'll continue working on this tomorrow.